Some people do say that even you don't really sleep until they're gone. But some other people, and I'm banking on them being right. They said, yeah, we can sleep more, but there are other problems. So like it mentions there, we're going to collect data in class in your groups. I don't care if you work together on discussing the report, but unlike the NIOSH lifting equation lab, I want you to write your own report and submit your own report individually. So work together as much as you like, but I'd like the words in your Word file to be typed by you, not copied and pasted or anything. And it's not, there shouldn't be tons of text in this report. I don't think it's going to be that long. Most of the space will be taken up by these tables and figures. So don't worry about writing a lot. Just make sure you communicate what you need to, and that's all you need. No need to add any fluff in. So we'll just go through this, I guess, in the same order it's listed. No, I don't have an example one, but the rubric that he has here is pretty good. Consider this the rubric in the deliverable part of this paper. I also posted this on Canvas in the module for work physiology. Just make sure you have each, I guess, let's go ahead and talk about the rubric. So make sure that you have everything that he mentions here in your report. And if you have that, then you'll be good. So you're going to select someone in your team, in your group, to be the subject. That's the person that's going to be doing the exercise. That's the guinea pig. You want to describe the subject. So, and he gives examples. All you really need is the age, weight, height, and gender. The task, just mention that we're climbing stairs for 10 minutes by DLC. And the objective of the laboratory. So the objective of this lab, so you might want to write this down, is to estimate the sub-maximal VO2 for for someone in your group. So the objective of this lab is to estimate sub-maximal VO2 for a person in your group. And that's it. We will use Astran's nomogram, that little figure, and you'll also create a chart and a couple of tables in the process. For the methods, you're going to describe the protocol. And so that protocol, let's go over that right now. So again, you'll find someone in your group who can do this, who's not going to pass out or have any problems. The person is going to ascend and descend the stairs over by DLC for 10 minutes. At the 2-minute, 4-minute, 6, 8, and 10-minute marks, you're going to record that person's heart rate. If you have an Apple Watch or a Fitbit or whatever, then you can just, the subject at the 2-minute mark can stop at the bottom of the stairs. You see, well, and then keep going. If you don't have one, that's fine. Do you know how to measure heart rate if you don't have a smartwatch or a fitness tracker? So yeah, you can use the neck, but you can also use the wrist. So why not use your thumb? Why do you want to use these two fingers and not your thumb? Because your thumb has its own pulse. So use your index and middle fingers on the wrist. If you've never done it before, then practice before we go out there. Just make sure that you can feel the pulse and count it. So if you can divide up roles however you'd like, but at least the person who's doing the exercise should not be the person with the stopwatch. So someone else will have a stopwatch or a timer or whatever, a clock on your phone, to keep track of the time and tell the person who's exercising when they need to stop and take heart rate. And the person who's exercising could either take their own, or the person with the stopwatch, or if you have 3 in your group, then it could be someone else. Does that make sense? Are there any questions about that? Okay. After you've done that, you'll record all of that, and then the subject will sit. Sorry, I'm having a brain fart. So the person who's exercising will sit for 10 minutes, and you'll measure their heart rate at the same intervals, 2, 4, 6, 8, 10 minute marks. And if you look at the chart on the 3rd page, you'll see kind of what that might look like when you graph your team members or your own heart rate. So you'll see at the 10-minute mark, there's kind of peak, and then it slowly drops back down to what is hopefully about your resting heart rate. Now, with this information, we're going to be calculating a few different things. This is just the raw data. So you'll need the person's age and their weight in kilograms. Does anyone know how to convert pounds to kilograms? Yeah, you can ask your phone. You can ask the internet. I believe it is 2.2, basically. So you would divide the pounds by 2.2 to get the weight in kilograms. So you'll just need, it's just these 3 right here. Then you'll take resting, the 2-minute interval marks, and then at rest, take heart rate at 2-minute intervals again. We didn't talk about how to use this in lecture. We just talked about kind of what it does. So let's talk about it now. You can see a line that Dr. Fogelman drew here, this darker line that is not dashed. It's a solid line. So you'll find your teammates or your own weight, and notice that on either side, so on the left side of this line, you have female. On the right side, you have male. So based on your gender, and then also based on your weight, you'll put a dot or something. And then at the pulse rate, you'll also put a mark. That pulse rate should be your that should be your max. Now, not your maximum heart rate that you calculate, but the max. Oops. This number here. So for this person, it was 122 at that 10-minute mark. That was the highest recorded heart rate. So that's what you'll mark down here. And you can see it's between 120 and 124. It's 122. That's for female. Where this line crosses this VO2 max line is your VO2 max. So you can see for this person, it crosses at about 3.4. Now, I was looking at some fitness blogs this morning and yesterday to get a sense for what is commonly used in terms of units for VO2 max. And these units are not commonly used. So I'm going to have you do a little bit of math to convert units to what is more common and what you could relate to if you were to look up information on VO2 max on a fitness website. So the units here are given in liters per minute. when you see something that's multiplied by something raised to the -1, that's the same thing as saying per minute. So liters per minute. If you look online, what's commonly used now, so I don't know if that was developed in the 50s. So things may have changed. What's commonly used now is milliliters per minute kilogram. So that's if we were to write it like that's written, it would be milliliters times minutes -1 times kilograms -1. Same thing, just different ways of writing it. To convert liters per minute to this, we've got to do a couple of things, and it's not hard, but I want you to do this. So let's use this person as an example. So they're at 3. I think the result was 3.4. Yeah, it is 3.4. They alternate the different sides to make more space here. We have 3.4. I should write bigger. Can everyone see? Maybe I'm just liters per minute. There's just 2 steps, and it's not too hard. How many milliliters are in a liter? Does anyone know what milla means or what mil in the Spanish means? So 1,000. Milla means it's 1,000th of, so 1 milliliter is 1,000th of a liter. So there's 1,000. So first you're going to multiply by 1,000. I won't do the unit analysis. You just remember these steps. Multiply it by 1,000 and then divide by the weight in kilograms. So this person, I want to be sure, 55 kilograms. So we divide this by 55 kilograms. And can someone do that math? So we're going to have 3,400, 3,400 divided by 55. $61.82. I don't remember. I did the math. I don't remember what I got. But does everyone else get that? Okay. 61.82, which is pretty high. So the average person is going to be, again, this is from a blog, so I didn't read this in a journal article or something. Not that journal articles can sometimes be flawed as well. I mean, I've published, so I know it's not perfect. If I can publish, then anyone with a pulse could publish. They just make it sound good. I didn't do anything unethical. I'm just saying, in terms of skill, it doesn't take tons of skill to publish a paper. Most people will be between 30 and 60. And again, it's in these units. So this number is in these units. So I would like you to convert it to those units. And then you can compare. There are charts you can find online that'll tell you for your age and your gender and your weight, what a good VO2 max would be. And we're not measuring VO2 max today. We're doing submax. If we were to do max, what do you think we'd have to do? Good point. Good question. It is the maximum amount of oxygen that you're able to consume. So the way they usually measure it is the mask. They'll measure how much oxygen you breathe in and then how much you breathe out. And the difference, and the key for max versus submax is for max, you have to be maxed out basically in your exercise. So you've taken it all the way to the limit before you can't do anymore. We're not going to do that today. I don't want you to do that today. Okay. It's going to be sub-maximal. So don't try to be Superman or Wonder Woman.
Sorry, so what's the final units? Is it the milliliters over?
Yeah. Yes. So from Astran's nomogram, you'll get liters per minute. So follow the steps we just did to convert it to milliliters per minute kilogram. And just for anyone who's, if you're going back to the recording or someone who wasn't here, we used this person as an example. So we took 3.4 liters per minute times 1,000. That converts it to milliliters. And then divide by the weight, 55 kilograms, and we get 61.8 milliliters per minute kilogram. The minute comes from the heart rate. If we were to look at all the units, we'd see that, you know, with pulse rate, heart rate, beats per minute, it's just a number per minute, and that's where the minute thing comes in. So VO2 max or submax is it's a basic measure of fitness and someone's ability to do work. I mean, we're talking about work. That's probably where it's most applicable for a lot of us, but also if you have a job that is somewhat laborious and manual, then you are at times going to be pushing yourself towards that number, your submax or your max VO2. We also, you're also going to be reporting your maximum heart rate and your heart rate percent heart rate range. I find this kind of funny. So Dr. Fogelman is kind of a stickler on captions for figures and tables, and I am as well. So in that way, we're aligned. If for figures, the caption goes below, and for tables, the caption goes above. So if we look at his examples, you can see the title and caption are above. Table 1, raw data. For the figure, it's below. Figure 1, Astran's nomogram. Again, we can see table 2 on top and figure 2 on the bottom.
So with this Astran's nomogram thing, is it literally going to be the exact same thing on this page, or do we have to do one?
So you will draw your own line. So the line will be different. It'll be the same figure, but the line will be different. You'll find your teammates' weight and their, I don't want to say their maximum heart rate, but the peak heart rate that they had during the exercise. You'll draw a line between the two, and where it crosses the VO2 max line is their sub max. Really, it's not there.
Can you look up the line?
Yeah, I mean, you could use that one too, or in the slides, there's there are some online as well. Although I couldn't find, I found one online, but if you look at the slides, there should be a bigger one if you want to do it that way. And I don't care if you do it digitally, electronically. So if you just pull up the PDF and you draw a line on that, that's fine as well. And then just take a screenshot of it. If you do it by hand, then just take a picture and put it in your report. So maximum heart rate, does anyone remember how to calculate that? We didn't actually do it in class. We just talked about it, but it's 180 minus the person's age. So max heart rate is 180 minus the person's age. It's sort of a rule of thumb for the heart rate that you should not exceed, or you might have trouble. Yeah.
It's 180 minus the age. I'm going to
Thanks. 220. I don't know where I'm getting 180. Where? It's 220. My wires are crossed here. So 220 minus the age. So this person must have been 21. That is a heart rate you should not exceed. Now, it's a rule of thumb. So you could go over it and be fine, or you could be well below it and have issues, just depending on your health. But it's kind of a rule of thumb, the heart rate that you should not exceed. And the percent heart rate range. Let's do it over here. Percent heart rate range, is heart rate exercise, like the peak. I don't know. I don't want to call it max because it's different. Well, I'll call it peak. Minus your heart rate at rest over your heart rate max minus your heart rate at rest. So these should be the same number. And you'll see here, I guess I didn't reverse calculate with the math to see which one they used here, but I'm going to say go with this one, because here you may still have some effects from your exercise. You may not quite get back down to your resting. So before we do the exercise, you're going to take the resting heart rate, and then we'll do the intervals. Last part of this, actually, that'll give you a ratio, a number below 1, and then you multiply that by 100%. So basically 44% here tells us that this number here, 122, was about 44% of the way to this person's maximum heart rate. For results, you don't feel like you have to type a lot, but do provide, like it says, a verbal explanation to help the reader understand what your tables and figures mean. So it could be one paragraph, maybe enough there. Just explain what's in each figure with more than what's in the caption. So, for this one, talk about raw data. And so talk about it, the characteristics of your subject, and that it has the interval heart rates during exercise and at rest. For the nomogram, talk about the results that you have here. Just, again, like a sentence is enough. For table 2, one sentence, just talk about what's in that table. And figure 2, talk about what's in the table. I think it would be interesting if you see something that's fairly interesting, then maybe mention it. A little bit of interpretation. For example, if you don't get quite down to your resting heart rate, you could mention that. I find this little jump here interesting. This isn't super scientific, so it could be that as you're going up and down the stairs, maybe towards the end, this person kind of felt the urge to push themselves, and so their heart rate increased more rapidly than before. And then for the conclusion, just interpret the results, basically. So this will just be one paragraph again, a few sentences. Interpret the percent heart rate range. So like I mentioned, here, percent heart rate range of 44 indicates that the person is 44% of the way to their max. you'll also interpret the nomogram results. So I want you to make that conversion, and the reason I want you to is so that you can compare it to, you know, what someone maybe should be at. Now, we don't want to disparage your classmates, but I mean, you're all young and healthy, so you have youth on your side. Let's see if I don't remember exactly what I was, what site I was looking at before, but stuff like this, if I can actually get there. Let me, the Red Bikini Project, I hope this is safe for work. Maybe? Okay. So you can see they use milligrams per kilogram minute, or minute per kilogram. And they have it for women and men. So just take your number from the nomogram, your converted number. So this person was 61.8. And I forget, it was the example male or female. I think it was female. So a female 20 to 29, and wow, she's that whoever the example was is like off the chart, like an athlete or something, maybe, I don't know, or a really long distance runner. So maybe some of you will be there, but if you're not in this superior column, don't feel bad. You know, if you're in here somewhere, then that's probably where, you know, my guess is you'll be, or maybe in the excellent. Again, you're young, you have youth on your side. So just compare it to that. Say it's according to the redbikiniproject.com. Just kidding. That you're in the good range or fair. I'm sure we can find this table from a more reputable source. But if you want to use the one from this recording, that's fine. Again, this is another blog. You know, not ideal sources, but mensrunninguk.co.uk. I'm not sure where you find a reputable source, but just compare it to something and say, according to this, you know, this submax VO2 is good or fair. Any questions before we head out? Yeah. I guess I'm not against doing it in different locations. With that, though, I guess, like, I can't be, if you have any questions, I can't be near everyone. But I would like the stairs to be similar, meaning, I don't know how many stairs are at DLC, you know, on the outside, going up to the upper level. Any guesses? Like 20, 30? So I'd like it, if you want to go somewhere else, find a staircase that is like that, continuous, you know, so like 20 or 30 stairs continuously without landings. And so like the stem staircase, I think, would meet that definition, if I'm not mistaken. Is there a landing in the middle? Okay. Like in the library, well, is there a landing? Dang it. Yeah. If you can find one that's similar to DLC, but somewhere else, I'm okay with that. I'm fine with that. Does everyone have their guinea pig selected? Okay. All right. And do you guys know how you're going to measure heart rate when you get there? So a real quick reminder, if you've never done it by hand, you'll need a watch or a clock. It could be on your phone. And for those doing it manually, I'd recommend doing it for 30 seconds, and then you'll double that number. So count the beats for 30 seconds. It's just to save some time, but count the number of beats for 30 seconds, and you may get 30 or 40. If it was 30 or 40 for the resting heart rate, then you would double that. So it would be 60 or 80, depending on which one of those numbers you got for their resting heart rate. It should be closer to 60. Again, you guys are all young. I don't, you'll all outperform me if I was also doing this. All right. So let's head down there.